Okay, chapter 12, problem 5. We have our rope strung between two posts. It has a force going down on it of 3160 newtons, and we know that it is sagged 0.35 meters, right? And we know that the length here, as that side of the triangle, is what would this be? 1.5 plus 1 point plus 0.22, so 1.72 meters. All right, all of that is just so that we can find out the angles everywhere. All right, because we want the angle here. We know that this force has a component in that direction, right? The tension from here has a component upwards that is half of the 3160, right? And this one has tension this way and has a component upwards that's also half of the 3160. So what we're really looking to do is find out, given the geometry and given that we know the length of we know the amount of force that's directly upwards, what would then this hypotenuse have to be, right? So this is 0.35 meters, this is 1.72 meters. That angle then is inverse tangent of 1.72 over 0.35, right? That gives us that angle. And then we've got the force of 1600 something, straight up, and the tension that has to be going this way is then what would that be? That would be this force divided by the cosine of the angle. Okay, so we just got to figure out the angle, and then we got to divide by the cosine. All right, so the angle that the rope is at with respect to the vertical there is inverse tangent of 3.44 divided by 0.35. All right, so let's get a tan 3.44 divided by 0.35, and now we need to convert that to degrees. 84 degrees, 84.2 degrees. Okay, and now 3160 newtons over 2, right, is the vertical component. 60 over 2, so 1580 newtons. Well, we know that the tension equals tension times cosine of theta, all right, equals this 1580 newtons. And so the tension then is just 1580 divided by cosine of 84.2 degrees. All right. Okay, equals 1580 divided by the cosine of, okay, I got to convert to radians, but there it is right there in radians. By the cosine of, okay, so 15609 or 15610 newtons. Okay, and that's it for problem 5.